So today I'm going to be talking about unlocking document intelligence, and specifically with the open source project Dockling. So first, let's go back and examine exactly what the problem is, right? With the growth of AI and with the amount of companies that are wanting to leverage AI now, one of the biggest bottlenecks we're facing today is with data, right? Data is used to train AI, you need data to inference against, but the majority of organizational data wasn't really created for AI training, right? It wasn't even necessarily created for machine understanding. You have organizations that have all these various very complex data formats, PDFs being the primary one, but you also have Word documents, you have scanned documents, PowerPoint documents, Excel sheets, and all of these data formats you want to be able to leverage in your AI applications, right? You want to be able to use that data for training. And as we start to run out of data, or not run out of data, but limit the amount of data that we have access to for things like model training, we need to be able to extract as much information as possible from the data that we have, right? We need to use our data as efficiently as possible for our AI applications. So what does it look like when we try to use some traditional methods for parsing PDFs, right? There's a ton of PDFs, a lot of organizations have PDFs, but PDFs aren't machine readable, right? They were built for printing, they were built for human reading, and if you look at what a PDF actually represents, it's just coordinates of characters on a page, right? It's just how do we actually print out to make a document look like this. The issue with that is when you try to parse the PDFs, you end up with limited amounts of information, right? A lot of the times you'll lose the page headers, you lose that structure, you'll lose the table structure, the image content is not going to be parsed correctly out of a PDF, the reading order, the line wraps within a PDF aren't going to be understood correctly. So all of these structural elements within the PDF will contribute to the value of the data itself. If we look again at some, and this is a more toy example that we like to show, but there was this article, and a lot of scientific journals that were peer-reviewed, they started mentioning this phrase, vegetative electron microscopy, right? One of them was even cited over 100 times. And for a long time, people just kind of went with it. No one knew what it meant. It showed up in scientific papers, so it's okay, right? It turns out, when someone decided to actually dig into where that phrase was from, in a 1959 article, the phrase vegetative and electron microscopy actually spanned that two-column scientific format, right? And this is a very simple thing to resolve, right? You have this two-column format, you just need to have two-column recognition, but it shows that the actual structure, the document structure and the reading order have significant implications for the semantic meaning of the document, right? If you look at what Dockling is capable of doing with just some basic structural understanding, you can see that the two-column format is going to be recognized, and so you have vegetative all the way separated from electron microscopy. So to introduce what Dockling is meant to do, Dockling is capable of parsing over 15 different document formats. It's an open source project that was actually donated to the LF and data from IBM Research. There's advanced PDF understanding, so there's page layout understanding, reading order, there's chart, formula, code, figure recognition, all these important metadata bits of recognition that Dockling is able to do to take your data and parse it into machine readable formats. There's a unified Dockling document representation format that Dockling converts into. We'll talk about that in a second. There's various export formats, so it actually allows you to export into Markdown, HTML, JSON, those three most common AI-ready formats. Also, because it's open source and very lightweight, you can run it locally. You can run everything locally. Everything can run on a CPU. Most processing pipelines can run on a CPU until you get a little bit more complex. We'll talk about that as well. There's a lot of ecosystem integrations with other various open source projects. There's extensive OCR support for PDFs and scanned documents, visual language model support. There's now audio and speech recognition, and there's a very simple and convenient CLI that you can use to run it. There's a QR code there that'll take you straight to the Dockling repo. Feel free to check that out. But a quick pre-recorded demo. So you can see here we have a very standard looking scientific paper, right? We've got some charts, tables, images. We have that structure there. Very simple to run, and this is all running locally on a Mac. You just run Dockling to HTML, you put a link to that paper, and in a few seconds you have a converted document. So here we actually have the document separated from the images. Again, we'll talk a little bit about that in a second, but when you look at the actual document itself, you see the structure is preserved, those headers are going to be preserved, list items are preserved there, you have those images, charts, the captions are preserved with those images. table structures preserved. You can see what's very nice about HTML and what docking is able to do is those merged cells are going to be preserved as well. So highly metadata rich and accurate extraction. Again, when we look at compared to those lower level PDF parsers compared to just strict parsing, you can see we have higher quality, it's still fast and it's still cheap, you can run everything locally, and now you have the structured export from your data. Okay, so how does Dockling actually do this? And let's get into some more of the technical bits, right? So there's actually 4 different document processing pipelines that Dockling has. The easiest one is going to be the programmatic pipeline, right? And it's a simple pipeline because it processes documents that already have structure in the metadata, right? If you think about Word documents, HTML, Markdown documents, all of those already have structure encoded into the data itself. So all Dockling needs to do is parse that document, assemble that docking document, and then from that docking document is how you're able to do the various exports and other operations on it. Again, I'm holding off on that for now. But there's also the standard PDF pipeline, which allows you to parse PDFs and scan PDFs. Within that standard PDF pipeline, there are various models that you can enable and disable. So it's a little more complex than the programmatic pipeline because now you have access to OCR models, layout analysis models, you have table structure models. Again, all of those assemble into that docking document format. The next level up is going to the VLM pipeline. So using a single shot visual language model, you can convert images or scan documents directly into docking document format, and then allows for the export. And then finally, we're not going to talk too much about it, but it is a relatively new pipeline. The audio pipeline allows you to take transcripts of meetings, for example, and output structured data from that as well. So the visual language model pipeline specifically is a little more interesting. If you think about VLMs being, so a lot of organizations have tried using VLMs specifically for document conversion, right? They're very good at taking in context of the document, retaining that document structure during the export. The issue with that is twofold. A lot of VLMs are very expensive. They're large models to operate, and so because of that, if you're running things locally or you have a particularly large corpus of documents, you have an inferencing timing problem, right? You can see with Qwen 2.53b, a single page will take around 25 seconds on a MacBook. Pixel 12b will take 287 seconds. The other issue with that is because VLMs are not trained specifically to do document processing most of the time, they tend to do a lot of hallucination, right? They're assuming things that don't necessarily exist within the document. They may try to fill in some of the blanks within your document. And so you still lose a lot of information with just pure VLM conversion, right? You lose spacing, you lose headers. Some of the headers might not be recognized correctly. Table structure may not be understood correctly, and generally lower quality conversion. So Dockling's VLM pipeline actually relies on custom trained VLMs for conversion. So the Granite Dockling model is actually a 256 million parameter model. If you have a concept of the scale of VLMs or LLMs, a 100 million parameter model is very small, very lightweight. You can see within 4 seconds it does the same conversion, of course with higher accuracy, right? It's tuned specifically to convert documents from scanned documents to this Dockling document format, which you're allowed to export. Most of the training data, in fact, almost all the training data is created using the actual standard PDF pipeline in Dockling. So you'll see that the export is very, very similar to just using the standard PDF pipeline. Why does it specifically stand out, and why does a overall Dockling pipeline stand out? You can see there are OCR and bounding boxes enabled, right? So very tight bounding boxes around images, bounding boxes around text as well. It outputs in this doc tags format. Again, it translates to the Dockling document format. We'll get into that very quickly. There's layout analysis, code formula, figure recognition, charts and tables, all the other things that the standard Dockling pipeline is capable of doing. The Granite Dockling model, this VLM model, is also capable of doing. And here we have a quick demo from Hugging Face. If you go on Hugging Face and you look up the Granite Dockling model, I'm sorry, I misspoke. It's 258 million parameters. But if you go on the Hugging Face and look up the Granite Dockling model, there's actually a demo space available to you. You can check it out. You can actually upload your own documents if you want. But as you can see, after conversion, you've got those bounding boxes. You have the same general output as docs, as the standard Dockling pipeline. You can also convert charts to OTSL. There's multilingual support as well. Basically, any of the things that you can do with the Dockling standard Dockling pipeline, and then on top of that, you have this other chart recognition and, of course, the multilingual support. The standard document pipeline also offers multilingual support, but let's quickly get into the Dockling document data model. And in fact, before we do that, I'm going to go and very quick, let's see. Can I see my mouse here? I'm going to very quickly convert a document so we can see the full Dockling document model. If you go just on Google and look up Dockling Workshop, we have a lot of notebook examples and code examples that you can try out if you would like to. This is one of them, but this is just a very basic conversion. So we're going to take the Dockling paper. Again, it's a very simple scientific document. We'll run the conversion. Should take couple seconds, and then allow us to also, we're exporting it into Markdown, and we're going to export into JSON. So JSON is actually the closest representation to the Dockling document that we have, and when we actually open up the Dockling document, we can see it's this very hierarchically structured JSON format, right? If you actually, let me zoom in a little bit. It's a very, very long document, but if you actually look at the code within the document, there's this deep tree structure that the document is represented in. So this Dockling document is able to represent the full document in this tree structure where every element exists in relation to other elements, right? If you think about a document with headers, all the text under those headers is going to exist in relationship with those headers. You'll also see that it labels the different types of text, right? There's going to be body text, header text, there's list item text as well, obviously images as well. Beyond that, it also stores the bounding box information, right? So every element is also exists with bounding boxes. That allows you to do that bounding box drawing on the document and also extract images as well. But again, highly metadata rich, structurally preserved document, right? So you have this tree structure document, you have all of this metadata that goes with it. And with that metadata, you can do some very interesting operations, right? And I want you to think about exactly what other things you could potentially do with this amount of metadata about the document. But if we go back and we just look at a basic extraction here, right? We have the images, we have the titles. You'll see you have this parent-child relationship between the title and the rest of the document. You have the captions that are stored in relation to the actual images as well. So again, very relationally based document structure, right? And from that structure is what allows you to do the exports into JSON, Markdown, HTML. So a lot of the times when I talk to people, they think, oh, well, Dockling does a conversion into Markdown or does a conversion into JSON. It doesn't actually do any conversion after it converts to that Dockling document format, right? From that Dockling document format, you're then able to programmatically generate the JSON or the Markdown or the HTML because of how much metadata already exists in the Dockling document format. So from the Dockling document, other operations you can do, all of them can be programmatic, right? You don't need any other like AI applications to create a Markdown from this document. So one of the interesting things that I like the most about what you can do with a Dockling document is chunking, right? I imagine a lot of you are already familiar with RAG. We talked about embeddings already. We've talked about vector searches. So when you want to convert a document and you want to embed that document into a vector DB, like Milvus, right, you need to chunk the document because embeddings models have some sort of context window. You can't just shove your entire document at once into one vector and be done with it. So how do you actually split the document in an intelligent way, right? Assuming your embeddings model has like a 512 token context window, you don't just want to say, okay, well, every 512 tokens, let's just make that a chunk, let's make the next thing a chunk, because then you have like sentences that are going to be split in half, you're going to have paragraphs that are split in the middle, you lose a lot of valuable information because when you search for something, maybe it appears in the second half of the paragraph, but you have it split, right? So Dockling, first of all, is able to do something called hierarchical chunking, right? It's able to take the actual structure of the document and chunk based on structure. So if you think about what I showed you before, it can chunk based on paragraph size, it can chunk based on body text, right? It can take specific elements. Each chunk within the document can be one single element within that Dockling document, which largely means that it's very structurally coherent. The more interesting thing you can do on top of that, leveraging that Dockling structure, is called contextualization. So if you think about a document that starts off with a forward, for example, right? And this forward maybe is like a page or two long, but that forward is too long to fit into a single chunk. So if you are to retrieve a forward out of a vector database after you've embedded it, you may only retrieve like the first paragraph of the forward, because only that first paragraph is going to mention forward, right? Only the title. The title may only exist in the first paragraph's chunk because of how chunking works, right? The rest of it may be each individual chunks, and so you lose out on the rest of the forward. What contextualization does is, because docking preserves that parent-child relationship between the rest of the body text and the title of that text, forward, or that title, will actually be applied to every single chunk that exists as a child of that text, right? And so what that means is, when you retrieve forward, when you search, hey, can you pull up all the pieces of text that are from the forward, it actually is able to retrieve every single element of text that exists under that forward category, again, because of that structural relationship. A couple more interesting things you can do, because Dockling is able to recognize different images within the document and is able to tag images as images. There's also this picture classification thing that Dockling is capable of doing, right? So Dockling can actually recognize different types of images. It can parse images independently and recognize, so like, this is a bar chart, this is a pie chart, this is a diagram, right? And so using that classification, what you can then do is, for example, iterate through your entire document and only process bar charts, right? Maybe you have a model that's specifically good at processing bar charts, and you want to only process the bar charts out of your document. Well, instead of having to go through your entire document and process every single image as a bar chart, you can actually iterate through the document, sort for only the bar chart pieces, and process them that way, right? Same thing you can do with like other images, right? You can process all of your images using a specific VLM without having to process your entire documents using the VLM. Again, this is because Dockling is parsing those images and storing them separately from the rest of the document, but preserving those bounding box and coordinate information, right? So each image is stored within the Dockling document, actually in base64 format, which allows you to process each of them independently from the rest of the document. Another enrichment model, Dockling also has LaTeX output, right? So you're able to take formulas within documents, extract them, export them specifically into LaTeX format. You can also detect various programming languages. Dockling is able to preserve the programming languages and recognize programming languages within that Dockling document representation. I think I'm running a little bit out of time here, but very quickly, there is also the importance of scale, right? So I mentioned that the Granite Dockling model, 4 seconds per page, still pretty long. So largely for scale applications, we don't necessarily recommend using a VLM regardless. But we actually worked with Hugging Face to create one of the largest data sets that was generated from PDFs specifically, right? We parsed over 475 million PDFs, or sorry, they wanted to parse over 475 million PDFs to create this data set. Initially, they actually used Roam OCR. They were able to process 356 million pages of those PDFs, but it cost them around $75,000. Using Dockling for the rest of the processing, they were able to process the remaining 918 million pages at a cost of only $35,000. So compared to traditional OCR methods of document processing and PDF processing, Dockling is actually going to be 50 times cheaper, and again, allows you to scale much faster, process documents much faster, much lower inferencing costs. Okay. So that is it for the Dockling presentation. I have a couple of QR codes up there. There's one to the GitHub page. There's one to the official Dockling.ai website. And then there's also one to the workshops. We actually have monthly office hours as well for Dockling if you want to join. I think LinkedIn for now, if you just look up Dockling on LinkedIn, it's there. We post notifications there for the office hours. We usually will have some people or organization that's currently using Dockling do a presentation on how they're using Dockling, lessons they learned in implementing Dockling, and then we have some recent project updates presented as well. But yeah, thank you very much. Are there any questions about Dockling?
So, having written this same thing 3 times in the past 6 months, I'm glad when I get to go back, I'm going to just switch over, kill off all my other code. The generating data sets, like in JSON-L, can Dockling help with that, or is that my problem?
So, to JSON-L specifically?
Well, I want to build a training data sets, and we're going through really quick. I didn't notice is there a step with Dockling where I can generate data sets?
Yeah, so you can export. Yeah, so you can export your data into JSON format. You can take those PDFs and then export them in JSON format. If you have data sets that need to be in a very specific structure, though.
Like ChatML or Alpaca or something.
So currently, there's not a supported export format into those specifically, but because those formats are largely very programmatic or like structured, you can take either the JSON export and do a programmatic conversion, or take the docking document. And so they're called serializers, is what we call them. So when you go from a docking document to any other format, you use a serializer to do that. And that includes like going from docking document to like a chunking, right? Because you're serializing, you're going through the document, and then you're exporting something slightly different. You could create a custom serializer using dockling to export into a format of your choice. Yep. Any other question? Yeah.
How big is that document JSON compared to?
It is, like in terms of storage, it's much smaller because the docking JSON is not storing like image content in the same way, right? It's not storing the resolution in the same way. If you look at like a traditionally parsed PDF, it's definitely larger, right? Because you're storing a lot of the structural elements. Actually, so I'm doing a separate presentation on recent project developments in like 2 hours from now. So if you're still here, we can actually talk a little bit about the storage formats too. Awesome. Well, thank you very much. I don't.